What is energy? Energy can be defined as a capability or ability to do work or to perform work. For example, as a human being, if you don't have energy, strength to move out, you can't go to school. Exactly. So that's the ability or capability to perform work. If you don't have energy, you can't move from one point A to point B. So the use of energy is same as that of use of work. And that's how you use what Jones. It's what Jones. You can represent that. Look at the forms of energy that we have. We have heat energy, chemical energy, nuclear energy, sound energy, light energy, and electrical energy. Look at the forms of energy that we have. Now let's look at the principle of conservation of energy. The principle of conservation of energy says that energy can be changed from one form to another. The total energy of a given system remains unchanged. That is, energy can never be created nor destroyed during what? Transformation. That's the principle of conservation is. So you have to recognize that conservation of energy states that energy can be changed from one form to another. And the total energy of a given system remains unchanged. That is, energy can never be what? Created nor destroyed during the transformation. So let's look at the mechanical energy. We have the two types of mechanical energy. We have the kinetic energy and potential energy. What is the mechanical energy? It's the energy of a body. The energy a body possesses because of the motion. All human beings have to be in motion, except for a dead person. All the chairs cannot be in kinetic energy. All human beings, because we move from one place to another. That's why we possess a kinetic energy, movement. Now, potential energy is the type of energy a body possesses because of its position or at rest. If you possess this kind of thing, you have to be at rest. Take for example now, all the chairs and table in our house will be in what? At the kinetic energy. They cannot move except you lead them from one point to another. That's why I said work and energy have the same units. Exactly. If you don't have the strength to do anything, you cannot perform any work. So you must have energy to perform work. If you are not eating, you cannot come to the lesson. So potential energy is the energy the body possesses because of what? Its position. Clear? So we'll stop at the potential energy. So let's look at examples. Let's have one of the examples of potential energy. We say potential energy is the energy at rest or position. Because all the objects in the universe will continue to be in a state of rest or except at the world by external force. So that's what gave us from the Newton law, first law, second law, and third law. Exactly for this potential, take off from the first law. Now, another example, a body of mass 100 kg kilograms is released from a height of 200 meters. With what energy does the body strike the ground? That is, with what energy does the body strike the ground? So we have to take it to be 10 meters per second. So if we strike the ground, that will be about potential energy. So computer potential energy is now giving us what? M. So we need to memorize the formula offhand as P equal to mass, assuming gravity and height. So we need to memorize that formula offhand, so don't forget. Mass times acceleration and height. So that is, from the question we have given mass to be what? 100. This is the mass here. So that means we have mass with this. Now we're given gravitational attraction is G. And also given height to be 20. Is that correct? So 100 times 10 times 20 gives us what? 200,000 joules. So now let's convert it to kilojoule. Divided by 1,000 gives us 200 kilojoule. Clear? So that we are having 200 kilojoule with this. This 1,000 now because we said 10 millimeter make 1 centimeter. 10 centimeter make 1 decimeter. 10 decimeter make 1 meter. 1,000 meter make 1 kilometer. So that we have this now. Now, what is kinetic energy now? Kinetic energy is energy due to motion. Example of kinetic energy are what? A rolling ball. That's what it's rolling. It's in motion. An object falling under gravity. We have a bullet movement. And also we have a plane flying. Is a what? Is a kinetic energy, something that is moving. Now, look at example of that now. Example, let's see how the example goes like now. We said kinetic energy is what? Example of kinetic energy, the formula for kinetic energy is what? R N B square. So a ball of mass 30 gram is running with a speed of 1 meter per second. What is its kinetic energy? And the formula is what? Half mv squared. So we have mass is what? 30, which is from the equation, and we have a speed to be 4, and that's we have 4 times 4. So when you multiply this, you give us that. Exactly, just give us what? 240. So some of you don't know how to do it. Just say half times 30 times 16. If you buy by this, give us what? 8. So 30 times 8 equals what? 240. And the unit is what? It's in joule. Now let's have another example again. A bullet of mass 40 grams is moving with a speed of 216 km per hour. Calculate the kinetic energy. So when I give something like this, we know that if we have to convert from kilogram to gram, that will divide by what? By 1000. So a speed of 260 km per hour. So when you have something like this, that means 40 grams will convert to divide by 1000, giving this. Now we have 260 km per hour. So that means kilometers when convert to meter, that will give us what? 1000. That will have 1000 there. So hour, 60 seconds make 1 minute. 60 minutes make 1 hour. That's why we have 60 times 60 other days. So when you divide, you have what? You have divide to meter per second. So 60 meter per second. So the formula is half mv squared. So what's our mass? Our mass is what? 0.4. Our velocity is going to be 60. So 60 times 60 was what? So when you multiply that, it gives us 72 joules.